All right. Hello, pre-calculus students. Today we're going to be walking you through the practice test. To be more precise, I will be walking you through the practice test. And I'll just be going through the answers, and hopefully that will help you finally correct your solution key a day before the test happens. So I wanted to give you guys all the time to try the practice test without the solution key. Now that you have the solution key, you should be good to go. All right. Problem 1. Use a graph to determine all local extrema for the function y is equal to 3x cubed minus 2x squared minus 4x. So what we can do is, by grapher, we can take our calculator, plug in 3x cubed minus 2x squared minus 4x, and then graph the function, and we can see we have a graph right here. And what we need to do is visually be able to recognize the extrema, and the extrema are going to be relative max, relative min. Okay, so as far as extrema, our vocabulary is concerned, we need to know that extrema, that's going to be relative max, which is what we're going to be worried about here, and relative min. Extrema also concerns with the absolute max and absolute min, but if you can see, just visually, the end behavior of this function approaches negative infinity, positive infinity. So there's going to be no absolute max or absolute min because the function approaches negative and positive infinity from the left and the right. So how do we find the relative max with our calculator? Well, this is a calculator skill. We can go to second calc and then find the coordinates of our minimum and maximum points. So let's find our minimum first. That is our minimum. So first we choose a point that's to the left of the minimum. So I know that that point is a little bit to the left of that minimum point. And I choose a point that's to the right of the minimum, which is right there. And then I choose my best guess, and that point looks like it's about on the minimum, so I hit enter. The calculator gives me a minimum coordinate, so that gives me a relative minimum. Gives me a relative minimum coordinate of the x value is 0.925. Let's round up to 3 places. X value is equal to 0.925, and then the y value is going to be negative 3.03. .036. Oh, actually 3.037. So that's relative min. And remember, we're just looking for the x values. So for A, that's the x values. And to find the relative max, we do the same thing. We find our maximum. When we go to a maximum point, we select left bound point and a right bound point, and then we find our best guess. We have a maximum of negative 0.481. We have our x value is equal to negative 0.481, rounding up to 3 points, and our y value is equal to 1.127. All right, now for answer A, we're just worried about the x values, and then for B and C, we need to find the relative maximum. Well, those are just finding the y values, so that's going to be 1.127. That's a relative max. And then the relative min is going to be the relative minimum is this y value right here, which is going to be negative 3.037. That's negative 3.037. And to follow good form, let's box our answers. All right, that is problem 1. Let's move on to problem 2. All right, graph the function, determine the intervals over which the function is increasing, decreasing, or constant. So we have f of x is equal to negative 2x minus 1 when x is less than negative 2. So let's graph negative 2x minus 1 first. So let's graph this in black. This is in black. Remember, this is only when x is less than 2. So it's going to be on this interval right here. And we have 2x minus 1. So we're going to graph the function at y-intercept of negative 1, and then we're going to have a slope of negative 2x. So we're going to go up 2 over 1. So up 2 over 1. And so this is where the function starts at negative 2. But because we have that less than sign, we're going to have an open circle. So that means we have an open circle at negative 2. And now that we have finished graphing the function, we don't have to graph it for values greater than negative 2. And we continue graphing the function. So we have an open circle at negative 2, up 2 over 1. So we graph the function, and we see that it continues all the way off up towards going in that direction forever. Now we have f of x equal to 3 from negative 2 inclusive to 0 inclusive. So we're going to represent this in red. That means starting at negative 2, right here, inclusive, so we have a closed circle, and going all the way to 0, f of x is just equal to 3, which just means we have a horizontal line at y equals 3 right there. Now the last value, which we're going to represent in blue, is 3x, f of x is equal to 3x minus 5. And so here, this is when x is greater than 0. We also know that that's going to be an open circle because that's not inclusive. So we have an open circle at negative 5 because that's our y-intercept. And then we're going to have a slope of 3x, which means we go up 3 over 1. So 1, oh, whoops. Sorry about that. Need to improve my counting. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. And so we can draw our linear graph as such. So if you know how to draw a function, all you have to do with the piecewise function is restrict the intervals. All right, so now we have to say whether it's increasing, decreasing, or constant. Well, here we can say, looking at that negative 2, that's an indication of a negative slope, which means the function is decreasing. So for this interval, we are decreasing. That's decreasing because we have negative slope. Then at this value, there's no change. It's a straight horizontal line, so that's constant. And then at this function, it's going to be blue. It's going to be increasing. Increasing. And the reason why it's increasing is because the slope is positive. So we have a slope of negative 2 here, which means has a negative slope. We have a slope of positive 3 here, so it's a positive slope. Negative slope, it's decreasing. Positive slope, it's increasing. A horizontal line is constant. Remember that dance I did. positive, negative, 0, undefined. Okay? Let f of x equals square root of 4 minus x. Find the inverse of f of find the inverse of the function. State its domain. State why f of x has an inverse that is also a function. Hint, to help find a function, you might want to graph f of x and its inverse. Okay. So let's just look at f of x is equal to the square root of 4 minus x. Okay. So let's find the inverse of the function. So we're going to find the inverse of the function. So to find the inverse of the function, we need to switch the f of x to y. So we have y is equal to the square root of 4 minus x. Then we switch the x's and the y's. So x is equal to the square root of 4 minus y. And we have to isolate the y, so we square both sides to get rid of that square root. So our next step will have x squared is equal to 4 minus y. And then lastly, we need to isolate the y. So we have x squared minus 4, subtracting 4 from each side, is equal to negative y. And then the last step is I divide each side by negative 1. So that way I can get y's to be positive. So I'll have y is equal to negative x squared plus 4. And this is a valid quadratic function. So I can write, so I said the inverse of the function is equal to negative x squared plus 4. So I found f to negative 1 now. Now I need f to negative 1 of x. Now I need to state its domain. For the domain of this function, we can say, can you take the square root? Is there any situation where you're taking the square root of a negative number? And we can say, no, there's no square root signs. There's no variable under negative number where we could take the square root of negative number. For this function, is there any place where we can say, is there a variable in the denominator that can make us divide by 0? No, there's no situation where you could potentially divide a term by 0. So there's nothing we can do that. And then lastly, there's a situation where we could take the logarithm of 0 or the logarithm of a negative number. And in this situation, there's no logarithm, so this is also a no. So in all three situations, these are no's. Okay. Now we have to explain why f of x has an inverse that is also a function. So this is a vocabulary term. So this is A. Well, sorry, almost done with A. Because there's no reason to restrict the domain is going to be all real numbers. So that's the domain of the inverse of the function. Okay. Now that's A. Now for B, we need to explain why f of x is an inverse as a function. So any function that is 1-to-1 1-to-1, we look at your notes on inverse functions. Inverse 1-to-1 means each input has one and only one corresponding output. Another way to check that is to pass horizontal line test. Passes the horizontal line test has an inverse that is a function. So when we look at f of x, which is the square root of 4 minus x, graphing the function, you will see that, let's go to pen, the function looks like that. It passes the horizontal line test. So the inverse of f of x is a function because f of x passes the HLT. So it passes the horizontal line test, so therefore the function is 1-to-1. So therefore the function has a working inverse. All right, determine the domain of this real valued function. Write your answer in interval notation. So we'll remember, whenever you have two domain restrictions, you take the most restrictive domain. So not only can you cannot take the square root of a negative number, you cannot divide by 0. So mathematically we can write x minus 2 cannot equal 0. Add 2 to each side. X cannot equal 2. So that's one statement we have to divide by. X cannot equal 2. The other statement we have to divide by is that the term inside the square root x has to be, it cannot be negative. So because of that, we need to take that term inside the square root x and say that x must be greater than or equal to 0. And that's another term we have to abide by. So with these two terms, how do we create an interval notation to express this domain? So x can be greater than or equal to 0. So right now, 0 is our lowest term we can be. So let's start with a bracket at 0. And we can go all the way up to values of 2. But we can't equal 2 because then we would divide by 0. So we go all the way from 0 to 2, but we cannot be inclusive. Then we can choose all values greater than 2, but not equal to 2. So I'm going to write a union, or we can go from 2 to infinity. And so that's the domain of f of x. All right. All right. So for the vertical asymptotes, the easiest way to do this is to find out, we factor the function and we figure out what cannot belong in the denominator. So we have x squared plus 6x minus 16. So the best way, so this can be factored as, you'll just get this with practice factoring. You can factor this into x plus 8 and x minus 2. And the reason why you can do that is because 8 times negative 2 is negative 16, and 8 minus 2 is positive 6. So So the values that would make your denominator equal to 0 is that you would have to have x equals -8 and x equals +2. That would make your denominator equal to 0. So these are our vertical asymptotes. All right. And to help find our horizontal asymptotes, what we can do is we can use our calculator and we can really look at the end behavior here. All right. So our function is 4x divided by x squared plus 6x minus 16. Let's zoom out. So we're graphing it and we're zooming out a little bit. Let's change our window. Let's make our x min -100 and our x max 100. This will truly see what's happening to the behavior as x gets bigger and smaller. All right, so that shows the graph. Now let's go to second table. Let's look at when x equals let's look at our table start at -1000. X equals 1000. Let's look at the y values. Looks like our y values are getting very small, so -0.004. And let's look at when x is equal to +1000, even +2000. All right, once again, these values are getting smaller and smaller and smaller and smaller. Let's just to entertain you, what if x, we look at 10,000? What's happening to that table? It's getting even smaller, and if you notice on the graph, you can look at this in Desmos, that it's going to be approaching 0 on each side. It becomes so small, the horizontal asymptotes are going to be approaching 0. So our horizontal asymptotes you can also look at this by end behavior. You can have a horizontal asymptote at y equals 0. Now, why would that be the case? Just want you to think about it. You have 4x as your highest degree term in the numerator and x squared as your highest degree term in the denominator. So as x becomes really big, or even if x becomes a really big negative number, as x approaches these numbers, the denominator is going to overpower the numerator. And whenever you have a number much larger in the numerator, because infinity squared, or a billion squared, is much bigger than a billion, that means that the denominator is going to overpower, and whenever you divide by a number much larger than the numerator, whenever your denominator is much larger than the numerator, the function is going to approach 0. So that's why you have a horizontal asymptote at y equals 0. So hopefully that allows you to think about it. Okay. Let's graph this piecewise function. Is the function continuous? Explain why or why not. So we have x squared minus 3 if x is greater than 0, and 2x plus 1 if x is less than 0. So x squared minus 3. Let's graph our parabola first. First thing we need to know is we start at the origin and we downshift 3. Let's do this function in red. So we downshift 3, 1, 2, 3, and then we have x squared minus 3. So where I'm going to draw a standard parabola. So let's look at an example here. 1 squared is 1. 1 minus 3 is negative 2. So we have 1, 1 and negative 1, 1. 2, 4. So 1, 2, 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. And 3, 9, 2, 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8. So now that I've drawn the parabola, I have to look at where the domain is restricted. So this is what the parabola will look like, but it's restricted only when x is greater than 0. So here's what I'm going to do. I'm going to delete all points where x is less than 0. And then because that's a not inclusive greater than sign, I can erase my point at the origin, right? Let me go to my eraser and draw a hollow circle at negative 3. Hollow circle, and I'm drawing that parabola going up. Now I have 2x plus 1 when x is less than or equal to 0. So here, when at 0, I'm going to have plus 1, and it's going to be filled in because it is inclusive with that less than or equal to, and we have the function 2x plus 1. We have a slope of 2, so we're going to have to go down 2, left 1, down 2, 1, 1, 2, left 1, down 2, left 1, and I have this function right here. So that's the piecewise function. Is the function continuous? So does that mean so the function is not continuous? And one reason is that you cannot draw the function without lifting your pencil off the paper. Oh God. Lifting your pencil off of that was a glitch. Paper. All right. So that's the next problem. Now we need to go to this problem. We find f of g of h of x, f of g of h of 4, and f of g of h of 1. So let's find f of g of h of x. First, we take h of x and we plug it into g of x. So we have 2 times, we take our term, h of x, times the square root of x squared. So the square root of x squared is just equal to 2x. That's just equal to 2x. So that's equal to g of h of x right there. So f of g of h of x plugs 2x into f of x. So that means f of g of h of x is going to be equal to, take that 2x and plug it into our f of x. So 2x cubed minus 2x plus 1. All right, so that's f of g of h of x. So that's A. Now we need to find B, f of g of h of 4. So now we just plug 4 into this function. So we have 2 times 4 cubed minus 2 times 4 plus 1. So 2 times 4 is 8. 8 cubed is 512. Actually, let me order of operations note here is that there's no parentheses there. So actually, before I write that down, you would what you would actually do is you would cube the 4 first. So there we go. Only the x is in parentheses. So 4 cubed times 2. So 4 cubed is going to be 64. So really, 4 cubed is 4 times 4, which is 16, times 4, which is 64. So 4 cubed is 64 times 2, which is going to be 128. That's going to be 2 times 64 minus 2 times 4 is 8. So minus 8 plus 1. So that's going to be 128 minus 8 plus 1. 128 minus 8 is going to be 120 plus 1 is 121. So that means the answer to B is 121. Now we have f of g of h of 1. So now instead of having 4 as an input, 1 is going to be our input. So we'll have 2 times 1 cubed minus 1 plus 1. 1 cubed is 1, so 2 times 1 is 2. Minus 1 plus 1 is just equal to 2 because those 1's cancel out. Alright, the graph of the square root parent function is shifted 2 units left and 3 units down. Then is reflected across the y-axis. Write the equation for the transformed function. So in general, when we have a transformed function, we have a times f of b of x minus h plus k. So that means 2 units left. That means if we're going left 2, that means h is equal to negative 2. 3 units down, that means that k is equal to negative 3. And a y-axis reflection, that means that b is negative. B is equal to negative 1 because there's no horizontal stretch, it's just that b is equal to negative 1. So here the parent function would be f of x would be the square root. So our root function would be f of x is going to be equal to the square root of negative, so the negative is going to be inside the square root function, and then we'll have x, well, let's keep this consistent. So we have a negative sign inside the square root function, then we have h is negative 2, so x minus negative 2 is going to be x plus 2, x plus 2, and then 3 units down, that k is on the outside. This is going to be minus 3. So that's that answer right there. Given the function g of x is equal to 2x plus 1 when x is less than negative 1, and x squared plus 3, where x is greater than -1, we're going to need to find g of -2 and find g of 0. All right, so we're looking at g of -2, and is -2 less than -1? It is. It's not greater than or equal to -1. So -2, we just plug it into this function right here. And remember, -2 is less than -1, so we go with the red function. This can be 2 times -2 plus 1, which is going to be -4 plus 1, which is equal to -3. Let's find g of 0. 0 is greater than or equal to -1. So we plug into the second function. So we'll have 0 squared plus 3, which is equal to 3. So that's g of -2 and g of 0. In the domain, find the domain, write your answer in interval notation. And so the main thing we have to worry about the domain is that we have a denominator, and we make sure the denominator is not equal to 0. So whenever we have a denominator like this, though, what we have to do is we have to factor the denominator. When we factor this, we'll have x minus 4 and x plus 1 in the denominator, which means that x cannot equal positive 4, because if x was positive 4, 4 minus 4 is 0, and x cannot equal -1, because if x was -1, we wouldn't be equal to 0. So x cannot equal 4, and x cannot equal -1. So now we just have to express this in interval notation. So we can have all values from -infinity up to -1 not inclusive, or we can have all values from -1 not inclusive to 4 not inclusive, or we can have all values from 4 to infinity. So that is our domain in interval notation. Graph the function on the axis on the right. So we have 2x over x squared minus 4. And there's no reason we can't use our calculator for this one. We will have the function 2x divided by x squared. Oh, let's put that in parentheses. X squared minus 4. And let's go to second window, second zoom, standard. All right, so we see our function graphed right there. So when we're graphing the function, more or less, we're copying the calculator. It looks like that's 1, 2, 3, 4. Okay. So at 4, the function is going to kind of do that. And then right here, the function has a little bit of that action going on. That's just a rough sketch. I'm going to state the intervals or the graph is decreasing. So here, the graph is always, seems like it's always decreasing. It's always either going down slightly here, and then on this interval, it's always decreasing a little bit by little by little. So the only values where it's not decreasing is at 0, where you have an asymptote. Okay? So all the intervals where the graph is decreasing. So I'm going to say from -infinity to 0 union 0 to infinity. Those are going to be all are in intervals just with 0 not being inclusive. Where is a function discontinuous? When x is equal to 0, because that's the one point where there's no continuity, where the function's approaching negative infinity from the left and infinity from the right. All right, let f of x equal 3x squared minus 5 and g of x equal 2 over x. Find f of g of x. Here we just plug g of x into f of x, so we have 3 times 2 over x squared minus 5. So that's 2 over x squared. That's going to be equal to 3 times 4 over x squared minus 5, which is going to be equal to 3 times 4 is 12. 12 over x squared minus 5. And to find the domain, we need to know that you can never have a denominator equal to 0. So we have x squared cannot equal 0. Take the square root of each side. The square root of 0 is 0. X cannot equal 0. So because x cannot equal 0 in interval notation, that's going to be from negative infinity to 0, not inclusive, union 0 to infinity. All right. Now graph the function f of x equals 1/2 times the absolute 1/2 times the absolute value of x plus 1 minus 3. So let's graph it. We're going to have a coefficient of 1/2 times the math number absolute value of x plus 1 minus 3. Let's graph that. All right, so we see we have a vertical stretch of 1/2, and we also have a left shift 1 and down shift to 3. So we go left 1, down 3. And if we go to our second table, we can actually plot points. So we have, my apologies, we have -1 and -3 as a point. Oh, whoops, let's graph that. So let's do the XY chart. All right. So x is 0. That means y is going to be the absolute value of 1 times 1/2. That's going to be negative 2.5, because 0 plus 1 is 1, and then 1 times 1/2 is 0.5, and 0.5 minus 3 is negative 2.5. All right, that's going to be negative 2.5. And let's verify that with our second table graph. We'll have 0, negative 2.5. So when x is 0, y is negative 2.5. But when x, right, like I said, so 0, negative 2.5, but we have a shift of left 1, down 3, so when x is negative 1, y is negative 3. When x is negative 2, y is negative 2.5. When x is 1, y is negative 2. And you can say the same thing for when x is equal to negative 3. So we have a function that looks something like that. So you plot points, but you can graph it on your calculator. All right, the last three ones. Find the inverse of the function 7x minus 3 equals 2x plus 4. So the first step is we switch the f of x with the y. So y is equal to 7x minus 3 over 2x plus 4. Then I'm going to, let me change my thickness, switch the x's and the y's. So I'll have x is equal to 7y minus 3 over 2y plus 4. I'm going to multiply to get rid of that denominator and multiply each side by 2y plus 4. Multiply x by 2y plus 4. So I'll have 2y plus 4 times x is equal to 7y minus 3. So then I'm going to distribute that x. So I'll have 2xy plus 4x multiplying each side by the x is equal to 7y minus 3. And then I want to get all my y's on each side. So I'm going to subtract each side by 4x. I'm going to subtract 7y from each side. So anything I do to one side, I have to be able to do to the other. So what's that going to get me? I'll get 2xy minus 7y is equal to negative 4x minus 3. I want you to look at what cancels out here. Those cancel out. The next step I can do is I can factor out a y. So I factor out a y. On the left-hand side, I will have 2x minus 7 is equal to negative 4x minus 3. And the last part is I can divide each side by 2x minus 7. Divide each side by 2x minus 7. Divide this side by 2x minus 7. This cancels out, and I've isolated my y. So I have y is equal to negative 4x minus 3 over 2x minus 7. And this is important for multiple choice tests, so that's the inverse function. But you can also express the inverse function as positive 4x plus 3 over negative 2x plus 7. Think about it. Just multiply it by negative 1 over negative 1. So these could both be your multiple choice answers, so be careful. Should the domain be restricted for the function x squared in order to make the function invertible? If yes, how so? Make your argument and explain your reasoning. So if you have f of x is equal to x squared, that's going to be a parabola that's going to fail the horizontal line test. So I'm going to say yes, domain should be restricted. So part one, I'm going to say yes, you're going to have to restrict the domain. If yes, how so? Make your argument, explain your reasoning. Well, if we restrict the domain so that x is greater than or equal to 0, essentially restricting the domain so that we only have for our parabola this part, then f of x does not fail the horizontal line test. So therefore, f of x is invertible. So that's generally what it's looking for. You should recognize you restrict the domain of a parabola in order to make it fit past the horizontal line test. All right. So we need to prove that these are inverses of each other algebraically. So in order to do that, we just need to find f of g of x and see that it's find that equals x. So let's prove that. It's going to be 1 over x minus 1 plus 1 over x, which is 1 over x minus 1. All right. So what is this equal to? Well, we need to find a common denominator here. So that 1, we can rewrite that 1 as, let's rewrite that 1 as x minus 1 over x minus 1. Remember that's equal to 1, but that allows us to add across a common denominator. This means this is equal to 1 plus x minus 1 over x minus 1, all divided by 1 over x minus 1. Here, that positive 1 and that negative 1 cancel out. So we'll have x over x minus 1 divided by 1 over x minus 1. When we divide two fractions, that's the same thing as keeping your numerator fraction x over x minus 1 divided by 1 over x minus 1, which is the same as x over x minus 1 multiplied by x minus 1 over 1. We see that our x minus 1's can cancel out, and that's equal to x over 1, which is equal to x. So we're doing a composition of the functions, and the answer is x. So if you do either one of these, that's going to give you x, which is the correct answer. All right, that's the practice test. Remind me if you have any questions.